Hi there, I'm Grant, one of the application scientists here at Edinburgh Instruments, and today I'm going to be demonstrating the effect contamination can have on your photoluminescent quantum yield measurements. Here I have two reference plugs, a quartz cap, and a sample of a bright phosphor powder with a quantum yield of approximately 93%. Under white light, both reference plugs appear uncontaminated. However, when viewed under a UV torch, it becomes obvious that one of the reference plugs is contaminated. Let's record some emission spectra from these reference plugs and our sample to see what effect this contamination can have on your PLQY results. As with every PLQY measurement, the first step is to load the reference sample, with a quartz cap in this instance since our sample also has one. We then launch the signal rate screen and select appropriate excitation and emission bandwidths to avoid saturating the PMT detector. Now I will record the emission spectrum of the Queen reference plug. For this sample, we will record the emission spectrum from 340 to 600 nanometers. We will use a step size of 10% of the excitation bandwidth, so 0.5 nanometers, and we will record a single scan with a dwell time of 0.2 seconds per step. With these parameters, each spectrum will take around 2 minutes to acquire, but for the sake of this video, the footage has been sped up. Now we will rename this spectrum Queen Ref, before loading the sample and measuring its emission spectrum with the same parameters as before. Once these measurement parameters are set, it's important not to change them between measurements of the same PLQY experiment. To do this, we can use the Rerun Measurement button on Fluorical's toolbar. To test the effect of cleaning reference plugs, we will use this emission spectrum as the sample scan for all PLQY calculations in this video. After renaming the sample emission spectrum, we will then load the contaminated reference plug and rerun the emission spectrum. We can now rename this spectrum Dirty Ref. Now that we have the emission spectra from the two reference plugs as well as the sample, we can import the sample spectrum into the different reference plug windows by right-clicking on the reference spectrum, selecting Insert Scan, and choosing the sample scan. We can now minimize the sample emission spectrum and calculate our two PLQY values. To calculate the PLQY of the sample, I will select the Quantum Yield Wizard of Fluorical from the Analysis drop-down menu. Today, we are analysing a solid sample measured with direct excitation only, and we will perform a standard analysis. We then assign the sample and reference scans before selecting the scatter peak range, which is 357 to 374 nanometers. We then select the emission range, which is 397 to 580 nanometers for this sample, and Fluorical calculates the PLQY. Using the Queen Ref scan as our reference, this was determined to be around 96.5%, slightly higher than the expected 93% of this sample. We can now repeat this analysis using the Dirty Ref scan as our reference. However, this time we will enter the scatter and emission ranges manually rather than highlighting them. This results in a PLQY determined to be around 104.8%, which is obviously an impossible result. So how can we clean these reference plugs? Fortunately, the process to clean the reference plugs is very simple. Today, we are using 800 grit emery cloth laid over a small cutting board. The reason for using the cutting board is to ensure that the final finish remains flat. The reference plug is then sanded in small circles under running water. The water ensures that any dust and debris is carried away. The dirty reference plug was sanded for around 1 minute, but I have sped the footage up. The reference plug is then checked under a UV light to ensure that the surface is free from contamination before being dried with a paper towel. While I'm here, I will refresh the surface of the Queen reference plug also. It's worth noting that if you do not have access to a UV torch, you can estimate when the surface is clean, as the clean surface will become very hydrophobic once again, as shown in the inset before and after videos. Back in the Applications lab, we will now remeasure the emission spectrum of both reference plugs by restoring the sample spectrum window and using the Rerun Measurement button. I then insert the same sample emission scan from earlier before calculating the two new PLQYs. For the dirty ref, the PLQY has dropped from 104.8 to 92.5%, and for the clean reference plug, the PLQY has dropped from 96.5 to 92.7%. The result for both reference plugs are now in line with each other, as well as the expected PLQY of around 93% for this sample. So to conclude, contamination can increase the calculated PLQY by over 10%, which can even result in PLQYs calculated to be above 100%. Even reference plugs which appear clean can benefit from sanding, as they can become contaminated from airborne sources such as dust and volatile organics, depending on their storage conditions. Cleaning reference plugs is a quick and simple process requiring less than 1 minute of wet sanding per reference plug, and we recommend that these reference plugs are cleaned by sanding approximately once per month, depending on the level of use and storage conditions in your lab. If you're interested in reading more about this, you can find a full technical note on our website linked in the description below. Thank you for watching.